All right, first I'd like you to notice the denominator has the radical in it with that trinomial underneath it. And this is a problem where we would want to use the completing the square method. So what I'm going to do is run through what that looks like when you have the negative out in front. Step 1 will remain the same. We're going to look at setting this equal to the 0. Step 2 will remain the same. We're going to move the constant or the c term to the right side. And then step 3 we hadn't used in the previous example, so I wanted to hit on that right now. We're going to have to deal with the negative in front of the squared term. So we're going to factor that out. That will make that 4x positive. I'll leave a blank to complete the square. Now we'll use step 4, so we'll find half of our b term, which is 2, square it, and we'll get 4. Now before you add to the other side, we must look at the negative here. That would determine the sign of the 4 that was just highlighted. We may have added 4 inside the parentheses on the left, but the left side of the equation was actually affected by a negative 4. Moving forward, we don't want to divide both sides by the negative and get rid of it because it needs to remain in the expression. We want the expression to be equivalent to, and if we divide, that means we're going to be changing the overall value of it. So now we'll go into step 4. We're going to write the left side as a squared binomial. And then we're going to move the negative 1 from the right, we're going to move that to the left. All right, after we do that, we're going to rewrite this integral. But before we do, right above here, I'm going to put the rule for arcsin. When we take the derivative of inverse sine, we end up with 1 over the square root of 1 minus x squared. Now that format is really important because we are working backwards from it. So the manipulation, well, that's just something we have to do. When I rewrite this expression into my new integral, I'm going to put the 1 in first because it's positive, and then I'm going to subtract off the squared term. We really want that order to be aligned. All right, from here we're getting ready to do the antiderivative. And the rule that we're going to follow, I'm going to show above. When we do the antiderivative of that inverse sine, we are going to divide. Some texts will do like a U and an A. We were using A and B, so I'm going to use B and A here. The B value that we have, that is going to be sorry, I was trying to change the color. That's going to come from underneath our radical here. So this is a squared and b squared. So that's going to come from that term that has the variable expression in it. Okay, so I'm coming back down to my integral, getting ready to do my antiderivative. The format is set up. The b value in this case is x plus 2. The a value is 1 and plus c because this is indefinite.